Welcome, I'm Professor Sever. Today we're going to look at the chain rule and look at several problems. So the first problem, we're going to look at f of x equal and on the first problem I'm going to break it down kind of step by step. Now again, this is not how we would actually compute the problem. We're going to get to the point where we'll compute it in what I would use as the second method, but I want to illustrate what's going on. Alright, so we have an inside function and we have an outside function, so let's see what they are. The inside function is g of x is 3x minus 6. Clearly we see this inside the parentheses. A little more precisely, it's inside the squaring function. Squaring function is written as h of x equal x squared. So what we're saying is, in this case, f is written as the composite of h of g of x. Okay. Now the chain rule, I'll illustrate it here. Again, under suitable differentiability conditions, namely h is differentiable at g of x, and if g is differentiable at x, then the derivative, we can compute the derivative of this composite thusly. So you apply the derivative of the outer function, that's h prime, you recopy the inside, so use the outer derivative rule. Then, oops, times the derivative of the inside, of course, I missed the prime. Then you multiply, this is the chaining, you multiply by the derivative of the inside function. So let's see. So let me do these again. This is what I said we wouldn't do. So I'm going to illustrate it this one time. So what is h prime? We're going to do all these on the side. The derivative of x squared is 2x. That's easy. The derivative of 3x minus 6 is 3. So what is h prime of g of x? That says in place of this x you put g. So h prime of g of x, I pointed to the wrong thing. I said g, but g is up here. H prime of g of x is 2 times 3x minus 6, right? And then we multiply by g prime. So by piecing it together, this piece is here, 2, 3x minus 6, multiplied by g prime is just 3. So the final answer, good form says we write what this is. Okay, so this is the derivative. So the derivative then is just 3 times, 2 times 3 is 6. And I would leave it in this form. It's already factored. If you wanted to write it out as 18x minus 36, you could. But really, the factored form is better. All right, that's how we do the function, the derivative in pieces, where we identify the g and the h separately, compute the derivatives of g and h separately, piece them together, then get the derivative of the original sought-after function, or originally sought-after function. So here's how we would do it in practice after you become a little more adept at the technique. Recopying the problem. All right, so now we're going to apply the outer rule first. This is how we apply the chain rule. The outer rule is the x squared rule, so the 2 comes down. That's how you take the derivative of the x squared, so that's what we did here. Recopy the inside. Decrease the exponent. Now times the derivative of the inside function. That's the part you don't want to forget. That's the part that's easy to forget when you're chaining. And you notice we have the exact same form that we had here. I didn't go through this writing it down on the side, and of course finally 6 times 3x minus 6, and I'll leave it in this form. This is what I would call the preferred form. Factored. Okay. Let's do another problem. And I'm going to do the next problem kind of this way. I'll do f of x, or f of t rather in this problem, is 5 sine squared t. Okay, now, certainly we could handle this in terms of the product rule, because sine squared is sine times sine. We've already learned the product rule. We're not illustrating that technique today. But you may not see an inside function yet. So for illustration, I'm going to rewrite the problem this way so we can see the inside function. Okay? Maybe for further illustration, I'll change the sign of the the color of the squaring function. Okay. Now we see a non-trivial inside function. By that I mean this is not just t. So what's the dummy variable of our function? If the inside function is not just t, we know we have an inside function scenario, potentially a chain rule scenario. All right. So let's do the derivative by the chain rule. We don't worry about the 5. Let's just move it out here. So now in these brackets, which I'll complete in a moment, I'm going to put the derivative of sine squared t. 2 comes down. Recopy the inside. Now the question is decrease the exponent, of course. Now am I done? No. Now this is where the chaining comes in. Now you have to multiply by the derivative of the inside function. So that's what goes here. See, this is the outer rule we just completed. So now in here goes the derivative of the inside function. And what is the derivative of sine? Well, it's cosine. So in particular, the derivative of sine t is cosine t. Okay. Now we always want to do the simple arithmetic, well, simple algebra really. 5 times 2 is arithmetic, but we always want to simplify. So 5 times 2 is 10. And finally, we obtain 10 times the sine t cosine t. And that's the final form of our answer, obtained by the chain rule. Thank you.